So, good evening, everyone. I hope I'm audible. Can someone please confirm that?
Yes, sir, you are audible.
Okay. So, maybe we can wait for maybe few minutes, 1 or 2 minutes, and then we'll start the session.
Of course, sir.
Okay, so I think we can start now. Uh, I hope my screen is also visible to everyone.
Yes, sir. Yes, भैया.
Okay, so actually, I was not expecting this much attendance, so I was thinking of having some introduction, but yeah, I think we can skip that because we have a lot of people. If you are willing
Yes,
to
sir.
write, what, sorry, yes, am I audible?
Yes, भैया, you are audible.
Okay, okay,
Yes, sir, you are audible.
okay. Yeah, fine. So, yeah, welcome to the live session for the course Digital Circuits. I hope you'll be having some enjoyable few weeks while doing this course because this is one of the easier course that we have in the NPTEL portal. And giving my brief introduction, I am Anant Singhal, a PhD student from IIT Jodhpur. We'll be having weekly session for this course to help you, basically help you in solving the assignments that have been given to you on the weekly basis. So I'm assuming this is your first live session for this particular course. I think there might be other live sessions also that might occur weekly from other TAs also. Uh, without maybe waiting for that, maybe we can start with the course. Let me admit few more participants.
भैया,
Yes,
it may be conduct continuously.
sorry.
Live session may be conduct continuously
Yeah,
on the basis of day.
it will be weekly. So I'll be taking one session every week for 2 hours from 6 to 8 every Friday.
Okay.
Yeah. Yes, so let me go towards the course outline. So this is, I would say, a very easy course. Please mute yourself, whosoever it is. Okay, still participants that are joining. Maybe let me. Just give me a minute. Yes, is there any doubt? Whosoever has raised their hand. Okay. So I hope I can really start now. There are still people that are joining, so I need to admit them all. So as you can see, this is a course outline that will be covering week by week basis. So in this particular lecture, we'll be covering some of the introduction of the digital circuits. and the main topic will revolve around the number systems. I think you all might be already aware of this particular topic because simultaneously the lectures are being taken or uploaded by the professor Shantanu Chattopadhyay from IIT Kharagpur. Is it useful if you write exam for this? Yeah, so it would be great because you'll be getting a certificate, NPTEL certified course that you have taken, and that might be applicable in your respective institutes also. And some of the institutes also, uh, I think, consider the credits of this course as a part of their regular curriculum. So it would be great if you can also enroll for the examination. Okay, so for resume, yeah, resume, it would be good that you have done some digital course. And okay, so the next problem is it related to the VLSI domain? So yeah, it is somehow related to the VLSI domain on the circuit level. So mainly, you need to have some understanding of the device level courses also, such as you need to have some prerequisite knowledge of what I would say is maybe semiconductor devices such as diodes and MOSFETs. So if you have some initial knowledge of that, then this course is also quite beneficial, adding on to your expertise, and it will be easier to get the jobs also in the particularly the VLSI and circuit domain. Okay, so the next problem is, can we do system design? Yeah, so you can also do, yeah. So Verilog is actually done, Verilog language is basically done to have some different kinds of models. So yeah, you can also consider doing all these courses that are being floated in the NPTEL portal. That would be great, and it is good to see such attendance in the initial week. So I hope this will be maintained on a regular basis for every week, because mainly the course will start around the week 7, that is the sequential circuits, as you can see in the week 7 course content, because that is the most important topic that is very much helpful in your gate exams also if you are a BTech student. And this particular course covers at least 10 to 12 marks of the gate exam also. That will help you a lot in doing that. So the course content will be similar to that. I may not be taking some of the gate problems, but yeah, the NPTEL assignments that you have been given, I'll be taking those problems or the similar problems that will help you in solving your assignments and also getting good marks in your exam. Yeah, so there are still people joining. Let's say, yeah, any doubt, Abhishek?
Then, भैया, in case of if any student doesn't want to take the gate exam, so
Yeah.
it can doesn't appear any gate exam, so it can be admission any MTech.
Yeah, so there are MTech in different domains. So these courses particularly taught, I think, in the BTech final year. So there are some MTechs that are being floated in the digital domain also. So that would be helpful for, I mean, this course will be helpful for enrolling in those MTech programs also.
Okay, thank you, भैया.
Yeah. So I request everyone to please write your queries in the chat box, since we have a lot of participants. So it would be better if you can write your queries in the chat box. I'll answer each and every query. Don't worry about that. Okay, so let me see. Apply for PLSI. No, so I don't think there will be any practical exam. So there will be an exam that will be held at some center that will basically check your knowledge that you have got, or the conceptual knowledge that you have got for this particular course at the end of the course in, I think, around October. I'm not sure when the exam happens, but yeah, it will be around after 3 to 4 months. So don't worry about that. I'll be covering all of this in the subsequent lectures. Don't worry about the exams right now. We'll be seeing, I think I'm not sure, but I think the format that we have in general is both subjective and MCQs that are taken by the NPTEL. So uh, yeah, and please don't open your mics. I again request you, if you have any query, you can write in the chat box. I'll be covering that. Yeah, so whosoever is raising their hands, you can write your queries in the chat box. So as I said, please don't worry about the exam pattern as of now. We'll be seeing at least for 3 to 4 months, we'll be covering each and every topic. As you can see, there will be week 12. There are 12 weeks of content to be covered. So we'll be seeing gradually that what will be the exam content, and uh, how this particular tutorials can help in the exam content, because the questions that I'll be covering will be mostly related to the assignment problems that have been given to you on the weekly basis, and that will really help you because I have taken almost all the similar problems that have been given to you on the weekly basis. I am assuming that the course week one content is already released by the Professor Shantanu, and you have already gone through this. So this particular week will be covering some of the number system problems. And then as you can see, subsequently we'll be doing some of the Boolean algebra and then some of the minimization using K-map and identities. Then we'll be going towards the logic gates and different circuits. And till week 6, it will be a course related mostly to the, okay, give me a moment. Yeah, so it will be mostly related to the combinational circuit. By combinational, I mean there is no memory involved in this particular course. And then from week 7, as you can see, sequential circuits, which is basically the memory circuits. And this part is kind of more important as compared to the initial part. But yeah, you need to have the understanding of the initial part also to be able to solve the problems related to the flip flops and the sequential circuit also. So yeah, without any further wait, I think we can start now because we have already been 5 minutes or 10 minutes into the course. Yeah, I think there are some more queries. Let me take them. So there's a course for topics like full adder. Yeah. So yeah, there will be topics like one's complement, two's complement, and full adder also. I didn't understand the theory. So yeah, I think the questions might cover some of the concepts that you might not able to understand in the theory lectures. Analog or digital must be given more emphasis. Yeah, so there are a lot of courses in the NPTEL portal such as analog circuits. Then there is semiconductor devices and circuits and semiconductor device modeling and characterization and all. So you can also enroll in those courses. Those are quite helpful for your domain expertise in the analog as well as the device level. What else? In the first year EC beside this course, could you please suggest? As I said, so I think first year in generally we have all the compulsory courses from all the branches. So from the subsequent year, we start to generally take some of the core courses of the branch. So yeah, it's good that you are still initially taking these courses, and these courses will help you a lot in gaining some of the concepts that are very helpful in covering the device as well as the circuit level physics. Then we have, yeah, so PDF will also be uploaded at a drive link that I think NPTEL team will share you the drive link soon. So I'll whatever content that I'll be covering in each and every lecture, the same day I'll be uploading that particular PDF in that particular drive link. And after that, this particular lecture will be uploaded on the YouTube regularly. So you can check the YouTube channel. Maybe let me write. So if you try to search my name with NPTEL on YouTube, you will see there are different playlists of different courses. So digital circuits is now one of them, and I'll be uploading at this particular channel the daily course or the weekly videos that will be covering each and every week. So you can also revisit and yeah, and proceed accordingly. Then yeah, PDF I've already told that it will be uploaded in the drive. These courses are all syllabus. Yeah, so every week we'll be covering the subsequent week topics that you can see in the screen. Then, okay, so ones and twos complement. Yeah, I'll be doing some of the problems related to that. Maybe I'll try to uh, solve that. And yeah, so maybe yeah, we can start now. I think we have already covered most of the problems. So yeah, I hope, okay, there are still more participants. Okay. Yeah. So let's start with the first problem, which is a very basic problem to start with. So each and every week will be, please mute your mic, please. I'm again requesting, do not open your mic and write your queries in the chat box. So I'll be covering one by one. Please, I hope I have covered almost all the queries that you have initially, but yeah, now we can start, and you need to see the course content as well as in the problems that are being covered. That will help you gradually, that will gradually increase your understanding of the course. So don't worry about it too much, and I think we can start now. So yeah, which of the following, so the first problem is which of the following decimal number is equivalent to this particular number. So this is nothing but a binary format, right? I hope you have already covered the initial content. Yeah, so every week we'll be having 2 hours for each and every section. So for binary, as the name suggests, we only have two possibilities that are either zeros or ones. Then we have different kinds of formats. So in general, what we use is a decimal format, right? So the decimal format is nothing but that we use in our daily life also, that is from 0 to 9, that are the whole numbers. Then we also have octal format in the in the number system, which is basically the number from 0 to 7. So let's say this is a number which is something called as ABC, and we have a base named as D. So this is what you see in general, a number written, and correspondingly there is a base written in the number. So you should always remember that these A, B, C are always less than the D. That is, the base is always greater than the numbers inside. This is one of the, I mean, key concepts or the basic understanding that you already should be having. And the second thing is, yeah, so as I told you, there are different formats: binary, decimal, octal, and then there is one more which is also called as hexadecimal, which is basically from 0 to 15. And we, since we cannot write a two-digit multiple, so we denote it by some of the alphabet. So I'll be telling you that in the further problems. So whosoever already know the answer to this, you can always post your answer in the chat box, and we'll be also covering this particular question side by side, and I hope you will be able to grasp all the problems. Yeah. So as a question suggests, it says which of the following decimal number is equivalent to this particular problem. So let's start with that. So the problem is 0 1 0 0 1 0 0 1 1, and it is the base 2. So each and every denotions that we have, so I have already getting some of the answer which are 147. So let's confirm that, and let me try to explain also how we can in general solve that. So let's say we have any base or any decimal number. So to solve that in the any decimal format or the basic decimal format, what we need to do is we need to write that base in the orders of 2 raised to power like this: 2 raised to power 2, then 2 raised to power 3, 2 raised to power 4. So this is how we'll be approaching to each and every problem. And then what we need to do is we just need to multiply each and everything by the corresponding number that has been given, and then finally we'll need to add each and everything. So this is a way to do at each and every base for this particular problem. Okay, so I think someone has raised their hand. Is there any doubt already? Okay, yeah, fine. So if you try to do that, so it will be 1 time, so the first digit will be nothing but 1 times 2 raised to power 0. So the second digit will be 1 times 2 raised to power 1, and if we need to add them, we'll be doing it subsequently. Then these are 0, so 0 multiplied by anything will always give you a 0. And then we have 2 raised to power 4 times 1, and the final one is around 2 raised to power 7 times 1. So if you do that, so 2 raised to power 7 is, if I'm not wrong, it's 128. Then we have 2 raised to power 4, it's 16. Then we have 2, and then we have 1. So if you do this, 14 and 3 is 17, then 4, 7. So as you can see, we have converted to the decimal base, and the decimal is always 10. Because in decimal, what we have is we have the numbers spanning from 0 to 9. I hope this is clear, because these are the very basic concepts that you already need to have the understanding of. Is it clear to everyone, this particular problem? It's good if it is
Yes,
clear.
Bhaiya.
Okay. So the correct answer to this problem will be option C, that is 147 to the base 10. Why 10? Okay, so 10 means because we are converting to the decimal format. You see, the decimal format basically spans from 0 to 9, and whatever the span is, plus 1 will be the radix or the base of that particular thing. So in decimal, we have a base of 10. In octal, since the number are from 0 to 7, the base are 8. In hexadecimal, since they are from 0 to 15, they are 16. Is it clear, Arushi?
Yes, भैया.
Okay. So yeah, so this was a simpler problem, and just to give you a very basic idea, even let's say we had something called as 123 raised per or to the base 4, and we need to convert it to, let's say, a decimal equivalent of 10. So how will you do it? Can someone do it quickly and let me know the answer quickly? This is a very basic problem, and this will test your understanding if you could understand this. Okay, so I already have an answer as 27. Yeah, so let me check now. So this is nothing but 3 times 4 is per 0. Then there will be 2 times 4 is per 1 and 1 times 4 is per 2. So this will be nothing but 16 plus 8 plus 3. And this gives 27. Yeah, that is correct, to the base 10. I hope the base are clear now, and this is how we solve any problem in general. Yeah, so maybe we can move forward to the next problem. So it says, which of the following hexadecimal number is equivalent to this particular thing? So whosoever already knows to how to solve it, you can try at your own, and you can write in the chat box. And till then, let me try to do let me try to explain how to do this binary to hexadecimal conversion. So there is a specific method to do it. Let's try to understand that. So if you have been given any binary number and you need to convert it to a hexadecimal. Okay, so I already got some of the answers, so it's good that you are already aware. So the problem that we had is 1010111001, and this is the binary number, and we need to convert it to the hexadecimal equivalent. So the steps that we need to do is, so the first step will be, you need to divide the binary numbers in a group of 4, and it should always start from LSB. So for example, what I'm trying to say here is, this is our number. So starting from the LSB, you should always make a pair of 4 like this. And if you are having lesser numbers, you should make a pair of 4, and you can anytime add 0 0, because that does not have any significance. Is the first step clear to everyone?
Yes, भैया.
Okay. Um, yeah. So now the second step, we can move forward to the second step. Once you divide it, what you can do is you can convert each group to its decimal equivalent. So this is the step 2. So the decimal equivalent of, let's say for example, for this particular number will be, let's say if I'm writing the decimal equivalent, I'm not doing it exactly, but I'm just writing the numbers. So 1001 will be 3. So this will be 9. The first decimal equivalent will be 9. For the second number, it will be 8 plus, so it will be 11 if I'm not wrong, and this will be 2. So this is how we have converted each of the binary number into the decimal equivalent, as we have learned from the previous problem also. And then the third step would be to convert. So in hexadecimal, what we have the digits from 1 to 9, and subsequently the 10 is denoted as A, 11 is denoted as B, 12 is denoted as C, then D. Since it is hexadecimal, so it goes up to 15. I hope you understand this particular thing. And now you just need to replace if there is any different component. So 1 to 9 will be written the same as they are, and if we have more than 9, so like for example, if we have a 11 in our particular number, so what I can write this as 2 11, as I can see it is denoted by B, and 9 will be 9 to the base 60. So this will be the answer to this problem. Is it clear to everyone this particular problem? So the correct answer would be option this 2. Okay, so I think there are some queries. I see. So why did we put 0 0 on the left side? Okay, so since we need to make uh, the pair of fours, so if I start from the LSB, so I made the first pair of fours, then the second pair of fours, then I was only left with these two particular number. So we know that 0, if we multiply it 0 with everything, it does not have any significance. For example, the decimal equivalent of 0 0 and this particular number and without 0 will be giving me the same thing. So that is why I need to make a pair of 4. So that's why I added two zeros because it is not changing anything, right? Does it make sense? Okay, yeah. If it makes sense, then I just created or converted the step 2 is to create the decimal equivalent and change the decimal equivalent to their corresponding hexadecimal equivalent. So this is the best and the shortest way to convert any binary number to its hexadecimal equivalents. Okay, and the other problem is what is LSB? So LSB is the least significant bit. Yeah. So we start from least significant bit means which has a least importance. So this is the least significant bit, and if we go from right to left, this is the most significant bit. Then we have explained from third step. Okay, so third step is nothing. So once you convert it into the decimal equivalent, we know that in hexadecimal there are 50 numbers, right? If I can write it like serially, you might be able to understand it. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is a decimal, right? Hexadecimal, as I told you, there will be 15 numbers, right? 10, 14, 15. So what we do in hexadecimal, since these are the same single digit numbers, we write them as same. But once we have a 10, so we cannot write 10 because that will make this number as, let's say, 2119, which is not correct, right? Because this is 11 actually, and we cannot write that. And if I do that, if I do the multiplication, it will be something 10 raised to power 2 times 1, which is not correct. So what we do is we denote 10 by A, 11 by B, and then correspondingly C, D, E, F. So that is why I changed 11 as B in the final answer. Does it make sense now? I hope it is clear. If it is not, please let me know.
Yes, Bhaiya, it is clear.
Okay. So maybe can you go back to slide where you written base numbers? Okay. Yeah. I solved a question related to decimal to octal conversion. Okay, so we'll be doing the octal conversion in the next problem. Let's see if you are able to understand this, and we might be taking your doubt also. Yeah. Let's move ahead. Yeah. So this is one of that problem that you might have done, or it is one of the similar problems. So it says convert 1 to 3. So 1 to 3 is the decimal. So let me clear that. So it is 1 to 3 base 10. So we need to convert 1 to 3 to its equivalent binary, then octal, and the equivalent hexadecimal representation. So I hope maybe I can give you also 2 3 minutes if you try to solve that by your own and write your answers in the chat box. Okay, so there is, I think, some more doubt. Let's see. Yes, whosoever is raising their hand, you can just type your doubts in the chat box. So here it's binary, then what it means is it's just base 2, octal is base 8. So the only difference that the hexadecimal and the octal is you need to make a group of 3 in octal. Oh, sorry, group of 3, yeah. And you need to make a group of 4 of binary in the hexadecimal. That is the only difference you need to do. You need to do to convert it into the octal or the hexadecimal. So yeah, just try it out, and if you have any query, we'll see later. But yeah, take 2 to 3 minutes and then I'll also try to solve the problems. You can type your answers in the chat box. Maybe A, B, C, D are the option, let's say. Okay, I see someone has already solved as B. Okay, so most of them are saying B only. So let me also now try to solve by my own. Okay, so 1, 2, 3 to the base 10. So the first problem is we need to convert it to the base 2, right? So the most common method that we in general use is we start by seeing that what is the maximum 2 raised power n that this particular number has. So for example, 2 raised power 6 is 64 and 2 raised power 7 is 128, right? So what we'll have is in the binary number we only have zeros and ones. So let me make 6 lines. So this will be, let's say, 0, 1, 2, 3, 4, 5, 6. So the maximum this number can go is 2 raised power 6, that is 68. So I'll write a 1 here, right? So if I do 64 is the maximum number, and the second number that I can maximum add is 32, right? So 64 plus 32 will give me 96. So I have got 96. I can also do 2 raised power 4. That would be giving me 102 and 1112. So I can also write 1 here. So now what I have left with is plus 8. So that will give me 120, right? So now what I want to do is just to add 3 in this particular number, right? So to add 3, what I need to do, I cannot add 4, right? Because if I add 4, it will become greater than 123. So what I can do is I can write 1 1 here, so that 2 plus 1 will be giving me that particular requirement of 3. So this particular number is basically nothing but 123 to the base 2. Make sense? Okay, I see. I can't understand. Okay, yeah, let me also try to do it in a simplistic way. I hope those who have already the idea are able to understand that. Let me do it in a very simple way also. So there is one more way that we can do this particular thing. So to basically change decimal to binary, what we can do is a multiple, like a long multi division of 2. So let me do that method that would make it very clear. So it is also called as repeated or successive division. So what we can do is whatever the number is, we can start by dividing it by 2. So let's say it will be 61 and the remainder will be, sorry, not here. It will be 61 and the remainder will be 1, right? Because this is 122. Does it make sense? So what we'll do is we in general write quotient at one end and remainder at the other. So quotient is 61, the remainder is 1, right? Now what we'll do is we'll divide 61 again with 2. It will be 30 and the remainder will be 1. So I can write 30, the remainder will be 1. So now I will do it again. So 2 divided by 30, so it will be 15 and the remainder will be 0. So the quotient is 15, the remainder is 0. Is there any confusion in this? Like the way I'm doing the division? I hope there is not. So let me do the division continuously. So if I do the 7, so it will be, remainder will be 1. Similarly, I think I can write now quickly because you are able to understand. So the remainder will be 1. Then it will be 1 and this is the final remainder basically. So now what we can do is we can just see this particular value upside down. So this will be your MSB and this will be your LSB. So this is what we just wrote. If you see 4 times 1, 0, 1, 1. So it will be, if I write an like a arrow like that, so it will be 1, 1, 1, 1, 0, 1, 1. So that is how I converted 123 into this particular binary format. Is it clear to everyone? Okay, so now
Sir, can you please explain again?
okay, so what I need to do is I need to do the consecutive division of 123 by 2 till I reach till I achieve this 1 as a reminder or the final number, and just write this is the MSB because this is what is getting multiplied by 2 raised power 6. Then this is 2 raised power 5. This is 2 raised power 4. Then 3, then 2, then 1, then 0. So this is what I did like by intuition here when I was doing it, that 123, the maximum raised power that can we have is 2 raised power 6 because 2 raised power 7 exceeds that. So we cannot take the 7th power. So here also you see we are also getting 7 digits and the first digit is 64 plus something. Why did you took 1 from the quotient? No, no. So 1 is the final. So 1 is a quotient. So let's say I reached here. So 2, when I was doing, I think 3. So it's 2, 1 are 2 and the remainder is 1. So when the quotient is 1, the remainder is 1, right? So I need to start with the last digit, whatever is the quotient. Make sense? Okay, I hope it is clear. So again, I need to do, let's say now the octal now. So what I can do is I can just divide it into a group of 3. Let's do it quickly. So this particular, if I divide into 3 and now I don't have 2, so I'll write 2 more zeros. So what is this in the decimal equivalent? Can anyone tell quickly? So this is 3, right? This is 7 and the final number is 1. So this is the octal equivalent. I hope it is clear. So similarly for the hexadecimal, what we need to do is we need to do a pair of 4. So let me do it from here. So this is the first pair and this is the second pair. So the hexadecimal will be nothing but, so the first number is 1011, which comes out to be 11, which is B. The second number is 0111, that is 7. So the answer would be 7B 170. Yeah, option B is the correct answer. Is it fine with everyone? Yeah, yeah. So this
सर
session,
आई हैव अ डाउट आई
yeah,
हैव अ डाउट
yes,
हाँ सर आपने ये कैसे मतलब 173 कैसे है 172 नहीं आ सकता
no. So when I was doing the formation of pairs, so this is 011. 011, the decimal equivalent is nothing but 2 raised power 0 times 1 plus 1 into 2 raised power 1. So it is nothing but 1 plus 2, that is 3.
ओके भैया इट्स क्लियर
Yeah, so let's move ahead now. So it says the minimum decimal equivalent of the number this. Yeah, so this is actually a good question. It will test your understanding. Yeah, so this session will be recorded. So it is currently getting recorded and it will be uploaded on YouTube. I've already given the name of the channel, so you can just go there and see the recordings after maybe 1 hour of the session. Okay, so I'll write it again. So you can search my name with NPTEL, you'll get this. So let me pin this thing. So I see already our answer is 75. Okay, that's good. So I've already pinned the channel name in the chat box. You can try. Okay. So can anyone, would anyone would like to tell how they have done it and how they are getting 75? Okay, so let me try to solve then if you are not willing. So it says the minimum decimal equivalent, right? So the number that have been given to us is 123. So now to get the minimum decimal equivalent, what we need to have is the minimum value of this base, right? So can I write 123 to the base 2? Yes or no?
No, sir.
Yeah, no. Why? Because there is a 3 inside or even there is a 2 inside the number. As I told you in the initial example, let's say a number is A, B, C and D. So these A, B, C should always be less than D. So even if I try to write 123 to the base 3, so this is also not possible because there is a 3, right? Oh, it's 1023. Yeah, my bad, my bad. 1 0 1 0 1 0. And now if I try to write 1023 to the base 4, can I write this?
Yes, sir.
Yeah, because now all the numbers that I have inside the conversion are lesser than that of the base. So this will be the minimum equivalent, or minimum decimal equivalent of this particular number. You just need to calculate it in the decimal terms. So let's try that. So it will be nothing but 3 times 4 is per 0, then 2 times 4 is per 1, then 1 times 4 is per 3. So this is nothing but 64 plus 8 plus 3. This gives me 75 to the base 10. So option D is the correct option. Is it clear to everyone?
Yes, Bhaiya, it's clear.
Okay.
Sir, decimal means 10, no, sir. Why did we take base as 4, sir?
So the question that has been asked to see that the what is the minimum decimal equivalent. So what we could have done is this number itself is not the decimal equivalent, but it is asking for the minimum. So if you would have written, let's say, 10 directly, so that is the actual decimal equivalent of this particular number. But there is no base given, so we have the opportunity to write as minimum value of the base as we can. So that is why we chose 4, because it is applicable as per the numbers that have been given inside. And then we calculated the decimal equivalent. As we do, let's say, if, for example, if we had a binary number, which was, let's say, this. So to convert it into the decimal equivalent, what we do is 2 times and 2 raised per 2 times 1, right? So this will be 5. So that is why we did the same thing. We multiplied by 4 and we got the decimal equivalent.
मिनिमम के लिए मैक्सिमम होता तो क्या होता?
Sorry.
मिनिमम की प्लेस पर मैक्सिमम होता तो क्या होता?
Your voice is not clear. Can you please repeat, or can you please write in the chat box? Is it clear, Pradesh?
Sir, it may be possible that our answer can be wrong.
Why do you think so that answer is wrong? It's correct, I mean.
Because when I was in a 12th standard, I was do that. My answer was wrong. That's why I ask you
Okay,
about that.
yeah, but I mean, if you find the logic correct, then the minimum number that would we have is having a base of 4. So that is why this answer is correct. So
So
one more query
yeah,
is
here
max.
you are doing 10, 1023 base to the base 4.
Yeah,
If we are doing 1023 base to the base 5, that's our answer will get wrong or right.
it will be wrong because that will not be the minimum number. We need to find the minimum decimal equivalent. So that is why we have chosen the least value that we can.
So, but how there can be some question said that our maximum decimal equivalent of the number find out. So how can we are find it?
So maximum can be anything. I mean, maximum is there is no limit. Even if you take base 100, that would be a number, right? So you cannot ask what is the maximum number, because maximum is not limited to anything. But we can limit ourselves to the minimum limit, because we know that the digits that are inside the equivalent are not cannot be greater than that of the base. So that is why the question has been asked like that.
Okay, sir. Okay, thank you, sir.
Yeah. Also, I'd like everyone, please, if you have query, please write in the chat box. Maximum
सर मिनिमम की प्लेस पर अगर मैक्सिमम होता है तो क्या होगा?
Yeah, so that cannot be a finite answer, right? Because as I already told, that this number can be as big as very close to infinite. So we cannot write what is the maximum number. Even if you like 10 raised power 7 here, that would be a number, right?
Okay, sir. Thank you.
Yeah, so maximum cannot be the logical question. That is what I'm saying. So sir, from the base 4 system, we'll get the minimum decimal. Yeah. So that is what we have got. 75 is
Sir,
the answer. Yes.
sir, one more explain, sir. I didn't understand that.
Okay. Okay, so let me try to put it. So it says, what is the minimum decimal equivalent of this number? 1023. So what I started with is the base 2. Can I write this? Whosoever has asked it out, can please tell yes or no. So can I write this 1023 to the base 2?
No, sir.
Why I cannot write?
So because we
Because
have
that
given the minimum number, so that we
Please, whosoever asked the doubt, please let him speak. Yeah. So who asked the doubt? I don't know. I think Pradeep. Yeah, Pradesh. Am I audible, everyone?
Yes, sir.
Yeah. So can I write 2?
No, sir.
No,
Yeah.
sir.
Can I write 3?
No, sir.
No, sir.
So minimum number that I can write, can I write 4?
yes sir.
Yes, sir.
So
Sir.
are you agreeing that this will be the minimum decimal number?
Yes sir.
Yes, sir.
Yeah.
Yes
So
sir.
that is why we have chosen
Yes,
it to
sir.
be the base 4, and then we calculated the decimal equivalent. Is it clear now?
Yes,
Yes,
sir.
sir.
Yes sir.
Okay.
Yes,
Great.
sir.
So I think we can move ahead. Yeah. So now the next query is the binary equivalent of -28 in the sign magnitude representation. Okay, so this is, yeah. So those who know can write their answer in the chat box. So let's say it's again A, B, C, D. So how I can find this is, we generally have a 8-bit representation. So there is a signed magnitude now. So the question is saying -28. So first of all, what I can write 28 in form of the binary number we need to see. So 28 is nothing but 2 raised power 16, that is 2 raised power 4, 16 plus 8. So let me write 1, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8. So while doing this 8-bit representation, what we do is, this bit is particularly reserved for the sign bit. So if the last digit or the sign bit is 1, that means we have a negative number, and if it is 0, then it means we have a positive number. Is it clear to everyone, this sign bit thing? Yeah. So since the number is negative, our first digit would be 1, right? So all of the options have 1, so yeah, there's no point then. So now I need to write -28. 28. So 28, as I can see, it's 16 plus 8, it's 24 plus 4, right? It's 28. Then 0 plus 0. So I can write this as 1, 1, 1, 0, 0. Does it make sense?
No.
So it's 1, 1, it's 3, 0, 0, right? So this will be 0, 0. So this is what is plus 28. And if I make the sign bit as 1, this will be -28. So the answer would be 1, because we need to write the sign bit as 1, then 0, 0, 1, 1, 1, 0, 0, and this is 28. Is there any option like that? Yeah, so answer would be option C. Is it clear? Yeah. Okay. So to write any binary
Sir,
equivalent, yes. Yeah, I'm
सर
repeating it.
हियर यू सर यहाँ आपने एक वन साइन बीट के लिए वन रिजर्व कर दिया वो नेगेटिव में, पर बाकी के जो तीसरे नंबर पे चौथे पांचवे जहाँ पे आपने वन लिखे वो भी नेगेटिव हम कंसीडर करेंगे.
No, no, no. So that is the actual binary number. So if you write 28 in binary form, it is 11100. So which is this
ओके
particular thing?
ओके सर.
So now since I need to represent my number in the 8-bit representation, so what we do, whatever the left bits are, we write 0, and the first bit is based upon the sign. So since the sign is negative, so that is why I've written 1. So this 1 comes from the negative, and then this particular number is 28, negative 28. Is it clear now to everyone? Yeah, because for the negative sign magnitude representation, we need to consider the minimum 8-bit representation. That is a rule. Okay, so there is one question that is posted in the chat box. Okay, so we'll see a similar question later in the lecture. Don't worry about that, the decimal equivalent. So if you are given a how do we know whether to consider negative sign? So it will say that the sign magnitude representation. Then only you need to consider the negative sign. because it is given minus 28. That is why we have taken. Otherwise, we would have taken this as a final answer, right? But negative numbers are, yeah. So negative numbers are represented in the 2's complement form. So that we'll see in the coming problem. So don't worry about the 2's complement. So that is correct. If you do the 2's complement of this particular number, that will come out to be 28. So yeah, just let's just leave that for now. So just remember that what we can do, I mean, just to write the process of this particular problem, the steps would be, the first step would be convert 28 to binary, which was nothing but 11100. Maybe you can write two more zeros to make it 8 bits, and then make, since we have a negative number, make sign bit to 1. So this will give me 1 as a first bit and thus a remaining number as same. So this is the rule. So this will be your final answer. This will be the shortcut or the way to do it. Is it clear to everyone?
Yes, sir. Yes, sir.
Okay, so there is one doubt. Why given? Because 1 represents negative and 0 represents positive. Okay, yeah. So let's move to the next problem, which is similar to the problem that has been posted by someone. So it says the binary equivalent of minus 25.675 in the sign magnitude representation. So again, remember it's sign magnitude. So the question has said that the bit before the comma is the sign bit. So since we have a negative, what would be the, what options can we eliminate? Can someone tell?
A and B will be eliminated.
Yeah, A and B cannot be
A
the
and B
answer
are positive.
because we have a negative sign bit. So the sign bit would be always 1. So now try to solve the problem and let me give you 2 to 3 minutes and write your answers in the chat box. I can already see some of the answers as C. So let's try to calculate. So 25, we need to just do the 25. So it will be 16 plus 8 plus 1, I think. So it will be 11001. So this is the 25. The sign bit would be 1 and the, yeah. So now after decimal, what we do is, so let's say something point, something is written, right? So to have that, we start with the first digit, that is 2 raised power minus 1 times something, 2 raised power minus 2 times something plus and so on. So we do not start with the 2 raised power 0 after the decimal point. So this digit is always 0, so we always start with the 0.5, right? So since the number is greater than 0.5, so I need to write 1 here. So this will be 0.5 plus half of that. That will be 0.25. So can I take 0.25? Please comment yes or no. No, because that will make your 0.6575 larger than that. Now the half of that would be 0.125. Can I take 0.125? Yes, right, because it will be something 0.625. Okay, I think 1010. Have I done it correctly? 0.5, 125. Oh, sorry. So this will be 0.175, not 25. My bad. Okay, so I see repeat. Is there a chronology to? Okay, so I'll repeat this particular thing. So after the decimal place, what I'm trying to say, let's say we have a binary equivalent. For example, if I would have said something a dot, so I'm not worried about this, but let's say it was 1010 to the base 2, and we want to find the decimal equivalent. So what I'm saying is I start the first digit multiplying by 2 raised power minus 1, the second by 2 raised power minus 2, and so on. So it will be 2 raised power minus 3 plus 0 times 2 raised power minus 4, and so on. To calculate it, we start with 2 raised power minus 1, that is half. So since this is greater than half, so this is 0.5, This is 0 because 0.25 if I write as 1, this will exceed because 0.5 plus 0.25 will give me 0.7 something, right? And this cannot be true because the answer is in 0.3, sorry, 0.6, and that is why I've taken the third digit, which is giving me, so the correct answer would be option C. Is it clear now? Okay, so whosoever has said to repeat, is it clear? Okay, yeah, great. So let's move ahead. So now, yeah, this is now the same problem. So let's do it quickly. Please let me know the answer in the chat box quickly. So this is option A, B, C, D. You can take 2-3 minutes and let me know the answers. I am expecting answer from everyone.
Sir,
So,
in the above problem, why didn't we take 8 bits, sir, for sign?
oh, because the question has stated that the bit before the comma is a sign bit. So the actual answer, if I say for minus 25, it would be 1 1 0 0 1. This is 25. So 0 1 2 3 4 5 6 7 8. So this is the actual representation, if that is what you are asking. Make sense?
Yes, sir.
Okay.
Thank you, sir.
So yeah, so this, did I get any answer? Okay, so option D, that is what I am getting. So let's write again 0 0 1 0 1 1. So this will be -1 -2 -3, then this will be 5 and 6. So basically the answer would be 1 by 8 plus 1 by 32 plus 1 by 64. So maybe, yeah, you need to use the calculators here. So it will be, so let me try to use a calculator and let you know what I'm getting. So it cannot be 0.7, as I can clearly see. You need to have, and this is 0.125, so this is not the possibility. Yeah, so the answer that I'm getting is 0.171875, which is option D. This is just a problem of solving, so I hope it is clear to everyone. Okay, so let's move ahead then. Now the problem is the number of ones in the 8-bit signed binary representation of -1 to 7 would be. Sir, in the previous question, why are we stop at 1010? Okay, where is 1010? I don't understand. Yeah, so I don't think there is calculator allowed. So yeah, let's just do this. Whosoever knows already, you can write your answers in the chat box. I can see some of the answers already, which are 8. Okay. So how do we, the number of ones in the 8-bit sign blah blah of this 127. So sign bit should be 1, right? Because it is minus. And 127, if I try to write in the 8-bit representation, so that would be basically all the ones, because 128 minus 1 is 127. So this is actually the case. So this is 127 and this is the sign bit, right? So the number of ones would be the overall 8, right? Is it clear? So what I'm trying to say is plus 20, if let's say it would be plus 27, so it will be 0 1 2 3 4 5 6 7. Now the question says minus 127, so the sign bit should be 1. So the total number of ones would be 8 here and total number of ones would be 7 here. Is it clear? This was a easier problem. I think we can move ahead. So it says now the number of ones in the 2's complement of a binary representation of this. So this is actually a good question. Okay, so I have one more query. In the sixth question, why we stopped at 1010 when we do the fractional part? Oh, so because the option only suggested 4 digits, so that is why I stopped at 1010. So since 1100 cannot be the option, the only option that I had was 1010. We could have done the exact, maybe some more ones could have been the answer, but the closest answer is option C. Yeah. So yeah, let's try this question out and maybe try to have some answer and let me know what is the answer that you are all getting. If if you are already aware about the 2's complement, so you can try out and let me know what is the answer. Okay, so I already see some of the answers as 2. So let's try that. So it says the number of ones in the 2's complement of binary number. So first of all, 2's complement of a negative number. So first of all, let's how we can do is we first write the positive number of that. So it is, I just calculated, it's 0 and 1, 2, 3, 4, 5, 6, 7. So this is plus 127, right? So how to calculate a 2's complement? So what we do is we first calculate the 1's complement, that is the reverse of the number. Reverse of the number. That is every 1 should replace by 0 and every 0 should be replaced by 1. So this is how we calculate 1's complement. And if we write or if we add 1 in the 1's complement, that basically gives you the 2's complement. Is this clear to everyone, this particular what to say method?
Yes, sir.
Okay, so let's try that now. So 127 is this 0, 1, 1, 1, 2, 3, 4, 5, 6, 7. So if I add 1, sorry, not 1. So the 1's complement of this will be 1, 0, 0, 0, 0, 0, 0, 0. And if I add 1 in this will be the 2's complement, right? So it would be 1, 0, 0, 0, 0, 0, 0, 1. So this will be the actual number. And what is this number referring to? So this is a 2's complement, right? So now, what was the question? The number of ones in the, oh, so the number of ones in the binary representation are only 2. Is it clear to everyone?
Sir,
Yes, sir.
should we discard one of the signs, sir?
No, since it was a negative number, so we need to consider that one. So if you remember, the question was for minus 127, we started with the positive 127. That is what we do. Then we do the ones complement and then we add 1. So whatever the result is the answer. So if it would have been an extra 1 or 0, so that would be the overflow carry here. There would have been one more bit that we would have discarded. But for this particular thing, we cannot discard that. I'll
Should
give
we?
one. Yeah, I'll give one more example. I know what are you referring to. So you'll be that would be
I
clear in some
mean,
of the further problems.
complement shouldn't be done to sign bits, sir.
Sorry.
The complementing one's complement shouldn't be done to sign bit, sir. That eighth bit,
Yeah,
seventh
that
bit.
is what I'm doing. So I have taken positive. That is why there is no sign bit, right? I mean, 0 is the 0. So I have done the complement of the positive number that has been given. Then after doing the 2's complement, that is the actual minus 127. So I hope you understand. If you do the 2's complement again, you will get the same thing. That was the problem.
Okay, sir. Yes, sir.
Yeah. So actually, the complement of plus 127 is minus 127. I think they are reversible. So that is why you are being confused. But yeah, that is fine. It will be clear in the further problems also. So let's move ahead now. Okay, so this is maybe some more. If the conversion of decimal to binary will get 8 bit, then what's the conversion of decimal? Okay, I did not understand the problem. If the conversion of decimal to binary will get 8 bit, then there is no problem. I mean, for numbers greater than 7 bits, let's say 127 is a 8-bit representation. For numbers greater than 127, there will be 16-bit representation. That is no problem. So it is true 2's complement of a positive number is that number in binary. Yeah. So it's not always true. There are some cases, for example, 127. 127, the 2's complement is 127 itself. I'm new to this also. What are the basics? Yeah, so we'll be covering basics only in these lectures. So if you are able to understand these lectures, then yeah, and it's always good if you can see the lectures from the professor that has been uploaded regularly on the NPTEL portal. Yeah. So all of you should try this particular problem. So this is more of what to say, solving problem. So just to give you an idea, what you can do is you can convert everything to the decimal equivalent and then try to find out the answer. Oh, so anyone has already, some of you have already find the answer. So it's good. Is there any three's complement? Yeah, three's complement is also there. There are different complement that we'll be seeing in the further weeks, if possible. So there are three's complement, four's complement, also five's complement, seven's. So all the complements are there. I don't know if they're covered in this particular course. So let me try to do one example for this particular problem. So first of all, FF16 is nothing but F is 15, I think. Yeah. So 15 times 16 plus 15 times 16. So this 15 plus, I don't know, what is this, 240. So this is 255 to the base 10. So just try to do and see if 245 to, I mean, this decimal conversion is giving you the same or not. So let me try to do example, maybe option 2 for option A only. Let's see what is option A. BAB minus ABA. So BAB is 11 times 16 square plus 10 times 16 plus 11 times 1 minus A is 10 times 16 square plus 11 times 16 plus 10. So this will be 256, 256. So 61281 plus. Please mute your mic, whosoever has opened it. Yeah, so minus this thing. So if I'm not wrong, this is 282987 and this is 2746 and this is to the base 10 basically. So this is 241 to the base 10, which is not equals to 255 to the base 10. So option A cannot be correct. So similarly, you need to check for all the options here. That is the way to do it. So let's do quickly for option B, which is BAA minus AAB. So let me do it directly quickly. 2986 minus 2731 and this gives me 255, which is correct. So option 2 is correct. Then option 3 is BA times 16 plus 45 times 16. So BA is 10 plus so this is 10 plus 16 times 11, 186 plus 40. Oh, this is also 16. So 64 plus 5. This is also 255. So option 3 is also correct. So this is also correct. So you can also check for 4. I think the correct answer to this problem is only 2 and 3 are correct.
एक्सक्यूज मी सर बेस 16 में बता दीजिए
Sorry.
सर बेस 16 में हेक्साडेसिमल
So yeah, we converted everything to the decimal and checked if they are equal or not. What exactly is your doubt?
सर विदाउट चेंजिंग डेसिमल प्लीज only
So yeah, so that addition is actually not very simple. It is a complex process, so that is why we do it in a very simple process. So I mean that the addition is somehow simple because addition we can still do. So for example, this BA plus 45. So A, we know it's 10, and 10 plus 5 is 15, right? So 15 we can write as F. Then B we know is 11 and 4. 11 plus 4 is 15, and we can write this as F. So addition is somehow simple, but for the subtraction we need to do the 2's complement and other things again. So that is why it's not very simple. And this method is simpler than that, to convert that into decimal and check. So that is why I have
Okay, sir.
done this. Yeah.
Okay, okay. Thank you.
So yeah, let's move ahead now. So it says compute the addition of the following two signed binary numbers, and this is the numbers. So maybe you guys take 2 to 3 minutes and let me know if you are getting some of the answers. One more thing, anyone, if anyone can make a WhatsApp group of this particular session, I mean for this particular course, and they can mail me the WhatsApp group link at the email that I have just written in the chat box. So I can join that, and all of you can also join that particular WhatsApp group. So is there anyone who is volunteering to make a WhatsApp group?
Sir, may I?
Yeah, who is this?
I am Abhishek.
Yeah, just make a WhatsApp group and send me the link of that WhatsApp group at this particular email. And for now,
Okay, sir. Of course, of
please,
course,
for now, paste that particular link in the chat box so that everyone can join that.
of course, sir. I will send you the link, and you can share the Gmail also.
I have shared you my email ID. You can share that link to me. And for now, please share the link in the chat box so that everyone can join.
Okay, sir.
So, is there any answer? Can you do a solution? Yeah, we'll see if needed to do the subtraction of hexadecimal numbers. Maybe I'll do it in the next lecture if you really need that. But as I said, the more simpler method is to just convert it to decimal and do that, because that will again represent or include a lot of complements and all. So I've got one answer as A. Are you not able to solve this particular problem? Anyone? Okay, so let me try to solve it. So now the question clearly said signed binary numbers, right? Signed, right? So this means this is a negative number, right? And this is a positive number. I hope you are able to understand this till now. So this is some negative number and this is some positive number. So if I try to just find the decimal equivalent, so it will be 0, 1, 2, 3, 4, 5, 6, so 64, 16 is 87. So this is plus 87 basically, and this is negative of 0, 1, 2, 3, 5, 6, 64. So I think it's 75. Yeah. So even if you could do a direct addition, so this will be something called as plus 12, and plus 12, the 2's complement of this number would be the final answer. So plus 12. 12 is 8 plus 4, 1, 0, 1, 0. So plus 1, 1, 0. Sorry, not plus 1. So it will be 0, 1, 0, 1 plus 1. So that will be 0, 1,
Sir,
1.
why we assumed it as an signed only? I mean, uh, two's complement representation also possible, yes, sir.
Sorry,
You have considered only it's as signed magnitude representation. Why you have not considered
I
two's
am not
complement
assumed it.
representation?
It is given in the question that these are two signed numbers.
Why we have taken magnitude representation only? Why can't we not taken like
Because
complex two's complement representation, two's complement representation?
yeah, so yeah, we will do that. I mean, I'm just telling you the direct way to do that. So let's do the 2's complement representation also. So this is plus 87, so that is fine because this is a positive number. So now to solve this particular thing, we'll do the 2's complement. Yeah, that is correct. So let's do that 1 1 0 0 1 0 1 1. So basically what I can do is
Most significant bit we can consider it as minus 127, and then
no.
remaining bits are as
So
same.
this is minus 75. So this is 75 and the negative sign is minus 75. So this is what I'm saying. Why are you saying it's minus 127? Minus 127 is all the ones when there are there.
Mean in two's complement representation we have represented like that, sir. Like,
Yes, so for minus 127, the actual binary number is 7 times 1. And since this is a negative sign, so that is why I added one more. I mean, I don't understand what are you asking. Is it
sir,
clear
for
that
example, if minus 10, how we will represent in two's complement, sir? Minus 10.
minus 10 in the signed magnitude, first of all, minus 10, for example, okay. So it will be 8 plus 2, right? So it will be 1, 0, 1, 0, right? And if I try to do it in 8, 0, 0, 0, and this will be 1. So this is the signed representation for minus 10, right? For example, at
Yes,
this
sir.
for this particular question, my minus 75 plus 87 is giving me plus 12, right?
Two's complement representation minus 10 what would be, sir?
I don't understand. So you are asking me to do the 2's complement of minus 10? Is that what is the question
Yes,
is?
sir. Yes, sir. Yes, sir.
Yeah,
Yes,
yeah.
sir.
So just do a plus 1. Oh,
Representation
sorry.
of
Yeah, yeah. Okay, fine, fine. So let's say this is the signed representation. So just revert all the bits and add 1. So this will be 1 0 1 0 1 1 1 0. So this would be a 2's complement representation of that number.
okay, sir.
Yeah. So for example,
How
here,
can we read for this is like this is minus 10. How can we read it, sir?
so if you do the 2's complement again of this particular number, you will get minus 10 only. I mean, you will get this thing. So that is why you can say that it
Like
is
why we not consider like what is the value of that number 6 and 6 plus uh, like in binary form why we consider it as signed or unsigned, sir?
because it is
How we
given in
find
the
out?
question. If you have given a 10, you will never write it. For example, this plus 12 is 1100. That is the answer.
Okay, sir. I understood. I understood.
For
Thank you so
negative
much,
sign,
sir.
you only need to consider all that. For
Okay,
example,
okay, sir.
since this particular question we are getting a plus 12, so 1100 will be the answer. That is this C. Is it clear now, everyone?
Yes, sir. Clear, sir.
Okay, so then try to do this. This is now again a good question that will again clear your doubts more. So it says represent minus 56. So you need to see minus is given. In the binary sign, then 1's complement, then 2's complement. So yeah, take maybe 2 minutes and quickly let me know what is the answer that you all are getting. So first of all, it is given minus 56. So what options can we eliminate?
A and B.
Yeah, so A and D cannot
A
be
and
the
D.
answer. Yes. So just quickly tell me, let me know what is the answer, B or C. Right answer for 11 is 1100. That is plus 12. So I've got one answer as B.
Sir, option B.
Okay, so we'll see. Some are saying C is the answer, some are saying B is the answer. Okay, so let me also now calculate side by side so that we can save time. Okay, so first of all it is minus 56. So if I try to write maybe initially plus 56, just to clear your doubt, so plus 56 is nothing but 32 plus 16 plus 8, I think. Yeah, so it will be 0 1 1 1 0 0 0, and since this is plus, so this will be a 0. So minus 156, oh sorry, minus 56 will be 1 0 1 1 1 0 0 0. Okay, so both of them are the same option. Now we can do the ones complement first. So what we need to do to do the ones complement, we need to revert all the bits, right? So to do the ones complement, it's 1 0 0 0 1 1 1. So this is the ones complement. It is 1 0 0 0 1 1 1. So yeah, option C will be the correct answer. B cannot be the answer. And then if I do the twos complement, that will be plus one of this. So it's 0 0 0 1 0 0 1 1. Yeah, which is this. So option C will be the correct answer. So those who are saying option B, I think you need to revisit and see what you have done wrong. Is it clear to everyone? Okay, great. Okay, now we have compute the addition of 28 and minus 36 using 2's complement. Select the appropriate answer in 8-bit 2's complement form. Okay, so the answer is given in the 8-bit 2's complement form. So you need to be clear about that, and please let me know what is the answer that you are getting. Take your time and let me know what is the answer that you are getting. No, no, after one's complement you have to add. I mean to convert
C option.
everything to.
Sir, it
C
is
option.
option C, sir.
Option C.
Yeah, yeah. So, okay, so already there is one answer that I've got, which is option C. Okay, great. So everyone is getting C only. So let's see. So the first number is plus 28. The second number is, let's say, if I write plus 36 first, because we need to do the two's complement only. So it's 0 0 0 1 1 1 0 0, and plus 36 would be 0 0 1 0 0 1. I think 32 plus 4, yeah, right? So minus 36 would be 2's complement of this thing. That would be nothing but 1 1 0 1 1 0. Sorry, not 0 now. It would be 1 1 1 0 0. So this is the 2's complement. So let me write the method. Let me write all the steps. So convert positive to binary. The second step would be convert the negative number to the 2's complement. The third step would be to add, because subtraction, I mean addition is required here. And the fourth is, if it starts with negative, sorry, if it starts with 1, then you can say the number is negative, right? Because we can clearly see the final answer would be, if we try to add these two, it would be minus 8. So if I just add this and this and then convert to the negative, let's just do that. So it's 28 is 0 0 0 1 1 1 0 0, then minus 36 is 1 1 0 1 1 1 0 0, and then we add it, so it's 0 0 0 1 1 1 1. So you see the last bit is negative. So since this is the 2's complement form, which is I think asked in the question, so that is why it is this particular option C is the correct answer. So even if you do the 2's complement of this, you will get the actual number. So let me give you that idea now. So if you try to calculate the 2's complement, so it will be 0 0 0 0 1 1 1 plus 1. So it will be 0 0 0 1 0 0 0. So you see this is 8, right? This is actually the final answer that we have got. So 26 minus 38. But the answer needs to be in the 2's complement form. So that is why this is the answer, which is option C. I hope it is clear to everyone now. This is how we do it. Is it clear to everyone?
Yes, sir.
Okay, so similarly, for example, let's say just to have more clarity, if the question was, let's say something 28 and minus 16, let's say. So we know 28 and minus 16 is nothing but 12, right? Plus 12. So if you could have done that overflow that you were asking for, so this is the example of that. So 28 is nothing but 0 0 0 1 1 0 0, and since this is minus 16, so it is 2's complement form is 1 1 1 1 0 0 0 0. And if you try to calculate it now, if you try to add it now, it will be 0 0 1 1 0 0 0 0 and 1. So there would be this overflow. That is what you are asking for, right? So but this is the actual 12. So we discard this one that I think you had a doubt about earlier. Someone had a doubt about. So if we have a positive number, then we need to discard one because we have a positive number. But if we have a negative number, then yeah, we just need to calculate what is the 2's complement form. Is it clear, everyone?
Yes, sir.
Okay, great. So I'll upload this particular PDF in the drive link that will be shared by the NPTEL team soon. I'm not sure if they have already shared, so I'll be uploading that in that particular link. Okay, so let's try to do this particular problem. Now, please don't take much time because this
Yes,
is,
sir.
yeah, so try to do it quickly because this is again a same problem and you have already been having some good ideas now. So it says 18 minus 52 by addition we need to do. So what we need to do is write plus 52, do the 2's complement of that. That would be minus 52 and this add the number. That would be your final answer. So I've already got one answer as D. So let's see if it is correct. Maybe I can give you 2 more minutes so that everyone.
C option, sir. C.
Okay, so someone is saying C now. So let's see which is the correct option. Maybe take 2 3 more minutes, and I would like all of you to try and let me know the answer. Okay, so see all of you are saying two as C as the answer. So let me do that. So plus 18 is directly plus 18. So 0 0 0 1 0 0 0 0. Sorry for the disturbance. So this is plus 18 and minus 52. So we just need to write plus 52, which is 0 0. So 52 will be 32 plus 16 plus 8. Yeah. Oh, plus 4. So this is plus 52. So do the 2's complement of this. So just reverse this digits and oops, sorry. So the 2's complement will be 1 1 0 0 1 1 0 0. Yeah. So this is minus 52 now, and we just need to add these two, which will be your final answer. So let me do that. So 0, 0, 0, 1, 0, 0, 1, 0 is 18. Then 1, 1, 0, 0, 1, 1, 0, 0 is minus 52 in 2's complement. So on adding, it is 0, 1, 1, 1, 1, 0, 1, 1. So 1 means it's a negative number. That means, so is this the answer? 1, 0, 1, 1, 1, 1. Yeah. So option C is the correct answer. Is it clear to everyone?
Yes, sir.
Can you
Yes, sir.
explain
Okay.
minus 52 again, sir? Minus 52 compliments, sir.
Yeah. So after doing the 2's complement, we just need to add the positive and the 2's complement. So if I try to add them, so 0 plus 0 will give me 0. Okay, let me maybe highlight. So 0 plus 0 will give me 0, then 1. This is 1, this is 1, this is 1, this is 0, 1 and 1. And by 1, we can clearly see the final answer is negative. That is, I mean, what we want. So that is why this is the final answer in the 2's complement form. That is what has been asked in the problem. So if you do the actual 2's complement of this number now, let's do that also. So it will be 0, 0, 1, 0, 0, 0, 1, 0, and which is actually 32 plus 2, that is 34, which is the actual answer in the negative value. So that is why this particular thing is minus 34. Is it clear?
Yes, sir.
Okay. So let's move ahead to the maybe the last problem or the second last problem. Yeah, so to try to do this particular problem. So it says 8-bit 2's complement of a number, particularly this number is what? So actually this is a good question. Maybe try it out and give me the answer in a few minutes.
B, sir. B.
तो इसमें बताओ कितना है जी वो क्वेश्चन पीछे जो थी आपकी क्या थी बोलो जरा
Okay, so
x स्क्वायर प्लस
someone is,
4x
please mute your mic, whoever is this. Yeah. So it says 8 bits 2's complement of this number. So you see the first digit is 1. So what will be the final answer? Is it positive or is it negative? Yeah, so how can everyone
Negative.
say B is the answer? These two cannot be the answer.
C. C answer. C answer.
2g कितना हुआ
Please
g
mute your
कितना
mic,
हुआ
whoever it is.
y का
D,
कोफिशिएंट
option D.
यहाँ पर y का कोफिशिएंट
Yeah, so let me try to do that.
वहाँ पे कांस्टेंट है
Whosoever is opening your
तो
mic again and again, please mute it. Yeah, so it is a negative number, so let's do the 2's complement. 0, 1, 1, 2, 3, 4, 5, 6, 7. So doing the 2's complement, it will be, I think, the same number again. So let me do that. Plus 1 is, sorry, not plus 1, sorry. So it will be 1, 1, 1, 7 plus 1, 0, 0, 2, 3, 4, 5, 6, 7. Oh, I've written one extra. 1. Yeah. So the 2's complement of this number is exactly the same,
Sir, D is the answer.
which is minus 128, which is option D.
I think it is start from 0. So minus 127.
Why it is 127? It's 128, right? Why are you saying 127? 127 is all ones and then a 1, right?
No, are we considering the eighth bit as signed bit only?
No, okay. So, okay, I see what are the doubt. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So here there are 8 bits. The first bit is 1, that is a sign bit. So when I'm doing the 2's complement, I'm not considering that particular bit. So I'm taking 7 bits only and then doing the addition. So this one is
But
from the overflow.
it's okay, but it is not mentioned in the question, na, whether it is signed data or unsigned data.
Yeah, so yeah, I have considered it as a signed bit. So that is why I'm saying minus 128 is the answer.
Okay, sir. If we consider it unsigned, then the C option is okay.
So if you consider it C, okay. C, why would be the answer be C? Let's see. Okay, 1, 2, 3, 4, 5,
I
6,
think
7.
answer would be C.
2, 3, 4, 5, 6, 7. So if I add 1, so then again it will be 1, 0, 0, 0, 0, 0, 0, 0. So, mm, so even that, if you don't consider it as a signed bit, that also will not give you that answer as C. But I think option B will be the answer, right?
Why we have to do 2's complement, sir?
Because the question is saying you need to do the 2's complement of the number.
Actually, they given 2's complement of a number.
Oh, okay. Yeah, yeah, yeah. So, oh, I understand now. Fine. So since they have given a two's complement of a number, I need to consider this as a signed bit because they have done a two's complement of a number which is negative, right? So the number which is the number which is the two's complement of this number, which is actually minus 128. If you write this as a signed representation, so it would be 1 and then 7 times 0, right? So if you do the two's complement of this number, it will come again as this number. So that is why I did not read the question properly. Sorry, my bad. Okay, what happened here? Hmm. I hope it is clear that the 2's complement of, if you do the 2's complement of minus 128, it will be minus 128. So this is the beauty of 2's complement actually. So whatever the like the actual powers, for example, the 2's complement of 64 would be 64 only. I mean, plus 64 would be minus 64 only. Similarly, 32, 8, and so on will be the same.
The answer will be 1 minus 127 itself.
Yes.
The answer will be minus 128.
The answer would be
No,
option D,
no,
yes.
minus 127.
No, the answer would be
Minus
minus
127, sir.
128. No, the answer would be minus 128.
Okay, sir.
Yeah. So yeah, is there any doubt in the problems that we have done till now? It would be minus 128. So I mean, I have tried to give you a very basic idea of the binary notations and the number system. So I think these are the very core topics that you might require to have the understanding of uh, before going into that. So I hope it would have cleared some of the understandings, and at least you are able now able to do some of the basic different types of questions which are related to this particular week, that is week 1, which was the introduction topic and the number systems topic. So in the next week we'll be starting with the Boolean algebra, that is again a very basic topic in which we'll be doing some of the Boolean algebra. That means we'll be having some of the expressions that we'll be solving and different things. And I hope this session has helped you a lot. So, by the way, has anyone shared that WhatsApp link? So, I hope you have already joined that group. And
Sir,
uh,
can you please explain question number 6, please, sir?
question number 6. Okay, yeah, let me go to question 6. Okay, what is question 6? This question?
Yes, sir. Yes, sir.
Okay, what is the doubt exactly? I mean, this is very simple actually. So, what part is the doubt?
So,
Is it?
what do you mean binary equivalent of
Yeah.
this?
So, this is a decimal number. We need to convert it to a binary equivalent. I mean, what is your doubt exactly in this problem? Is it the decimal part or is it the absolute part?
Sir, decimal part, sir.
Oh, so So 0.675 we need to convert to binary. So that is what I said in the next problem. We start with 0.5, right? So can I write it as 0.5 plus? I cannot write it as 0.25 because that will exceed. So I can write 0.125 plus something something, right? You agree with that
Yes, sir.
in the decimal
Yes, sir.
terms? So this is 1 times, this is 0 times, this is 1 times, this is 0 times, and so on. So 0.5 plus 0.125 will give me 0.625, right? So
Yes, sir.
since
Yes.
that was the closest answer of 1010, so that is why I choose this, because A and B cannot be the answer because of the sign bit, and C and D, this 11 cannot be the answer because this has already exceeded 0.675.
Yes, sir.
Excuse me, sir.
Yes.
So can you explain third question, sir? Conversion to octal. I am getting the wrong answer.
Okay, okay. Third question is this. Okay. Octal, you are saying it's wrong. Okay, let me do that. Option, where is question 3?
Sir,
Wait,
sir, 1 second. There is a no have doubt, so we can leave the class.
yeah, if you don't have any doubt, you can leave.
Okay, sir. Thank you, sir.
0, 1, 1. So this is the binary number. So for octal, as I said, you need to start from the LSB and make a pair of 3 instead of 4. So this is one pair, this is one pair, and then this 0, 0, 1 will be the third pair. So this 0, 1, 1 will be 3 in decimal. Then this triple one will be 7, and this 0, 0, 1 will be 1. Is it clear now? I mean, what answer did you get, or what was the wrong thing?
Sir, I was getting when I have added, sir, I am getting 107.
I mean, you can see, right? It's 173, right? This box is 3, this box is 7, and this is 1. I mean, are you able to do it now? See if you have
Once you
done,
can,
yeah.
once you can write and explain also.
So if you have done the binary part correctly, let me emphasize on that. So if you have done the binary part correctly, so this thing, that is the first 3 digits, this is 0, 1, 1. So, right? You can say this is 3, right? 0, 1, 1 is 3 in decimal.
Yes, sir.
Then 1, 1, 1 is the next 3 bits. So you can say it is 7, right? Are you able to
Okay,
understand?
sir.
And then this
Okay,
zero
sir.
zero 1 is 1.
Okay, sir.
Yeah.
Excuse me,
Okay.
sir.
Yeah.
Sir, what is meant by signed and unsigned?
So signed and unsigned means, so for every signed magnitude, actually we have unsigned numbers are basically which are the numbers that are starting from 0 to some positive value. Whereas signed magnitude is the negative numbers also. For example, if I say it in 8-bit system, it is from -127 to +127. Whereas this unsigned is from 0 to 127.
If
That
last
is
question considered it as unsigned, then it would be minus 127, right, sir?
128 -128.
Consider it as an
Please explain last one.
unsigned signed.
Yeah, so since it says the 8-bit 2's complement of a number is this. So if I try to do the 2's complement of this, that would be the actual answer, right? So let's do the 2's complement. So ignore this bit because this is what are the sign bit is. So if I do the 2's complement of this thing, so that would be all the ones, right? I mean, the ones complement will be all the ones, and if I add 1 in that, that would be again all the zeros with a overload of 1, right? So that is again the same number. So this is actually -128.
Yes, sir. Yes, sir.
Yeah.
Sir, it's 256, no, sir. Last bit indicates.
Sorry.
Sir, seventh bit in last one. That means 2 to the power of 8. That is equal to 256, no, sir. Not
No, no, no,
128.
no, no. So 0, 1, 2, 3, 4, 5, 6, 7. So this is the 8th bit. It's 2 raised per 7 times 1, which is 128.
Okay, sir. Thank you, sir.
Yeah.
Yes.
So I think we are running out of time, and we can, if you are any query, you can mail me anytime, and maybe I can write my mail. So this is my mail ID. If you want to have any query, you can also post it in the WhatsApp group that someone has created. So this is my mail ID. You can mail me anytime if you have any queries, and we will be meeting weekly every week Friday from 6 to 8 p.m. And I expect each and everyone to join the classes regularly. That will help you in good understanding of this course. So as I said, we are running out of time. So if you have any query, you can ask me over email. So those who are writing in the chat box can quickly
And
mail me.
can we get these questions?
Yeah. So I'll be uploading that in the drive that has been given to the given to you guys by the NPTEL team. So if it has already not been given, so they will be providing it soon. So you'll be getting this particular PDF, and along with that, the YouTube recording will be uploaded like in an hour span from now in the YouTube channel.
Thank you very much.
Yeah. Thank you everyone for joining, and let's meet at the next week at the same time.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.